Welcome back, students. In this video, we're going to cover lesson 3-4, writing proofs. This is take 2 for me. Just finished the whole video. Normally, and if you're just tuning in, I don't normally have stuff written. There's a lot of writing in this particular lesson. I tried to pause, but the good to the program I use now is the camera's a little more stable, but the bad is I can't pause it to try to edit or cut down on my pause. When I'm writing and stuff like that. So apologize. It's going to be written, pre-written. I'm going to do a lot of explaining. So easier for you guys that are just here to copy the notes. But for those of you that are here to actually understand the material, then I ask you to listen. I will apologize up front. I was back home this weekend for homecoming. Shout out to the class of 95 from West Blockton. So my little twang is a little more twangier. And I'll just apologize up front. So let's get right into this. So we're starting proofs for you guys that are in the class. If you, at the bottom of the page, I've added the word bank. It wasn't on the original copy, and this will make things a little easier. I'll kind of go through this. I'm not going to write the check-in, but if you listen, I will give you the answers. You just have to listen to what I'm explaining to you. So, keep vocabulary. So on the left here we have postulates, and these are not something you got to memorize. They'll just be useful for below in a couple of these examples. So starting on the left, postulate 3-1. Through any 2 points is exactly one line. And that's true for if the plane is the sheet of paper that I'm on, that the notes are on, or let's say halfway between your TV, your screen and my paper, there's another point. You could draw a line there. Between any 2 points is a line. 3-2 says that through any 3 non-collinear points, there's exactly one plane. So if you remember back to module 1, we said you needed 3 points to identify a plane. All right, 3.3 says a line contains at least 2 points. So you got another PQ statement. So through any 2 points P, there's one line Q, and a line Q, contains 2 points Q. So you got down here 3-4, a plane contains at least 3 non-collinear points. So if this statement through any 3 collinear points was your P, going back to a previous lesson, then down here, at least 3 non-collinear points, there's your P. Your Q is exactly one plane. A plane, Q contains exactly 3 points. So these are the converse to one another. 1 and 3 are the converse to one another. Sorry, just pointing that out. Excuse me. 3-5. If 2 points lie in a plane, then the entire plane containing those points lies in the plane. 3-6 says that if 2 lines intersect, then their intersection is exactly 1 point. And 3.7 says if 2 planes intersect, then their intersection is a line. All right, to the right, so these are your key concept, how to write a proof. So step 1, you're going to list the information and draw a diagram. Step 2, you're going to create a deductive argument that links the given info to the statement that you're proving. Step 3, justify each statement with a reason. Reasons include definitions, postulates, theorems, and algebraic expressions. And step 4 is state what you have proven. All right, so moving right along. Like I said, I've done this video once, so I'm going to try to... The first one was 25 minutes. This one should really be like 10 because everything's written, and I'm hoping you guys will listen up. So, all right, so example 2, determine whether each statement is sometimes, always, or never true, and justify your argument. So A, ask intersection of 3 planes is a line. So this wasn't mentioned above. They talked about 2 planes, but did a little research. You guys are welcome to check the book. But the answer to this is sometimes, and it's because planes can intersect at a point, a line, and I was reading or plane. I just don't know if 2 planes intersect, like they can intersect at a 2 planes could intersect at a plane, because that would make them the same plane. But perhaps I'm overthinking. If you have anything with this, please comment or send me a message on Teams or Focus. All right, point B, or number B. Line R contains only point P. Okay, well, up above it said that you needed 2 points to make a line, and a line contains at least 2 points, but they also contain infinite points. We learned that in Module 1. So the answer to B is never. And then C, through points H and K, there's exactly 1 line. So this is, the converse to that. So this is always between any 2 points is a line. All right, example 2, check. Determine whether each statement is sometimes, never, always, or never true. Justify your argument. And 2 intersecting lines determine a plane. Look up above, and the postulate will be there, and that'll give you the answer. So we're going to go ahead and scooch down again. So for 3 and the 3 check, I put the word bank there. It was not there before. So number 3 on the left. Complete 2-column proof. So our given is that Q is the midpoint of PR. So about 95% of the time, the first statement and the first reason are going to be your given. Sometimes you'll be given more than 1 statement, like over here. But for this one, we were given 1, and that's where we start. And again, almost always. All right, so the next 2 were blank. Now, you can see in the word bank. Now, they had PQ. We had to prove PQ was congruent to QR. All right, so if Q is the midpoint of PR, we know that PQ is equal to QR, right? So that's what we choose here, and we choose it because Q is the midpoint. So the definition of a midpoint means that these 2 guys are congruent. All right, so then notice from 2 to 3, we have the same PQ. This is equals QR, and that's because we're dealing with numbers. Here we're dealing with the actual shape. The line segments are congruent. They're the same measure. And equals and congruence means the same thing, so it's the definition of congruence. We will have this a lot. Equals to congruence or congruence to equals, and it's always the definition of congruence. So example 3 to the right, the check. So you got your word bank here. So I'm not writing it in, so hopefully you're listening, but your given is that B is the midpoint of AB and C is the midpoint of DE. So you know what that means, and you know what to mark with your colored pencils. The first statement were those 2 statements, B being the midpoint of AC and C the midpoint of DE, and those were given. Your number 2, so because those are midpoints and you see there's 2 of them, only one choice below has two. It's AB equals BC, comma, DC equals CE. And why are those 2 things equal? It's because we were given the midpoints, B and C. Number 3 says that AB is equal to DCE. And that was the third given. See, so this one had 3 givens. There's your third given. Okay. Number 4, blank, blank. Well, you have a BC equals CE. Notice above, number 3 says AB equals CE. So if we're just changing from AB to BC, we're substituting it. So the 4th reason is substitution, and the 4th statement is BC equals CE. So I'm going to flip the page over now for those that have paused the video to write their notes and weren't listening. On the back side, I did try to put the word bank. It just didn't work. I'm not going to write it on the right. I'm going to tell you again if you're listening up. So example 4, and I apologize. I don't know why we're struggling to stay focused. Let me hit the focus lock. Ugh. Biscuits. Bro, there we go. All right, so example 4, back page. So write a statement and reason in each box. So they tell us that P is the midpoint of JK. So I drew a line up here. I drew JK and I put P as the midpoint. And because P is the midpoint, I know these two are congruent, so those are the orange marks. So my first blank, I put JP was congruent to PK, and why? It's because it's the definition of a midpoint. Again, you guys will have word banks, but that's why I'm extra explaining this. All right, so our next one was JP equals PK. Well, I just told you it was congruent. They're telling you it's equal. Why? Because those two things mean the same thing, but we say the definition of congruence. Now, this was not mentioned, but if we had the drawing, you would have seen that X is what they told you JP equaled, and 5X minus 8 is what PK equals. So if JP equals PK, we put X equal to 5X minus 8. We just substituted. We substituted X for JP, and then 5X minus 8 for PK. Up here, notice that they subtracted 5X from both sides. I know we usually do the little from the big, but they did it the other way around, and they just wrote it this way, but they subtracted. So 5X minus 5X is negative 4X. 5X minus 8 leaves negative 8 because these two cancel. They're showing it as a substitution. I think that's an extra step, but that's my opinion. All right, so divide each side by 4, so division, and then when you divide it out, so the 4's cancel, you're left with X equals 2, and that was what we were asked to solve. We just didn't have the word bank. So to the right. So flow proof, they give you that these two things are equal, so you can go ahead and mark them as congruent also. Let's see. So you would substitute so if FG is equal to HK, you have those measures, you would put those in here. You'd say 4X minus 6 equals 22. So you substituted FG for the 4X minus 6, and you substituted HK for 22. Then down here, you're going to add your 6 to both sides. So it would be 4X minus 6 plus 6 equals 22 plus 6. We just wrote it long ways instead of short, kind of like they did over here. So once you do that, you're adding. So that'd be the addition property of equality. All right, so once those, negative 6 and positive 6 is going to leave you with just 4X. 22 plus 6 is going to make 28, so you just substituted those out. 4X equals 28. We're dividing both sides by 4. So division. Once you do that, those the 4's cancel, so you got X equals 28 divided by 4, which should be X equals 7, and that is what they asked you to prove. So you just put prove or solve there. Okay. Moving along again. Apologies for pre-written this. I paused a few times because of so much writing. So our example 5 asks to write a paragraph proof. Luckily, we're not asked to do this a lot, and never the whole thing like this. So that's why I wrote it for you. Over here, you have a paragraph proof. I've given you there's 5 blanks. There's 5 of these. And I'll tell you without writing it if you're willing to listen. So, but over here on 5. So, given that C is between A and B, so wrote A and B, put C in between them. They tell us that AC is congruent to CB, so I marked those. And they want us to do a paragraph proof to prove that C is the midpoint. All right, so given that C is between A and B, and that AC is congruent to CB, by the definition of congruence, AC is also equal to CB. So we changed from congruent to equal. So because AC is equal to CB, so just repeating, comma, we know that C is the midpoint. Why? Because the definition of a midpoint. If these two are equal, C has to be the midpoint. So that's how we did it. To the right, so they give you that Y is the midpoint here, so you would mark these. And they told you, and they're saying that that this guy and this guy are congruent, and they're wanting to prove that this guy and this guy are congruent. So So given y is the midpoint of those, and those two are congruent. All right, so because y is the midpoint, and because these two are congruent by the by the definition of the midpoint. All right, so xy is congruent to wy is given. So by the definition of congruence, wx is also equal to y, wy, and xy is equal to wy, xy is equal to wz. And by the symmetric property of equality, xy is also equal to wy. Xy equal to wy can be written as wy equal to xy, so we can flip it. Excuse me, 2 plus 3 equals 3 plus 2. And then lastly, by the transitive property, because xy equaled wy, and because xy equaled wz, and because wy equals xy, then wy equals yz by the transitive property. You got more than 2 involved. Okay, down at the bottom. So your summary, if 2 points lie on a plane, then the entire line contains those points. That contain those points lies in that plane. And the number 2, why is it important to learn different proof methods? I want you guys to look that up in the book. If you don't know where the book is, please comment below or send me a message on Focus or Teams. Please consider liking the video and subscribing. If you have any questions, let me know. Again, if you're not in class, comment, and if you are in my class, or if you're at First Coast, please send me a message in Focus. But if you're outside First Coast, comment to the video, and I'd be glad to help you out. Until next time, have a great night.